there is that guy in Facebook. His name is Pete Hunt. He is like manager there, whatever. He once gave a talk 3 years ago. It was like 20 minutes talk about some weird shit nobody understood at that time. But 3 years later, everybody is using React. And he was talking about why React better. When I saw this talk first time, I didn't understand, but 3 years later, I watched it again recently, and I finally understand that. His talk was captioned, Rethinking Best Practices. And he really rethought best practices for UI development. So that's why I named my talk the same way, Rethinking Best Practices. His video on YouTube has like 100,000 views, which is too much for a tech talk. I'm hoping this video will be the same. Okay, so hello, I'm a developer, Vasil Borovyak, and welcome to the Vasil Borovyak Presents Fun with Stamps. This talk is going to be really complex for people who do not really into development for some time. It's not really a talk for junior developers. And please ask.
Say if that's you, by the way. There is a second talk.
Please ask me any questions anytime. Just raise your hand, and I will stop immediately. We'll be answering your questions because the thing will be quite complicated. Okay, so how typically a class inheritance looks? Well, you have a, let's say, class with a constructor, method X, and property A. And then you need to add, you need to reuse the implementation. To reuse the implementation in Java or C# in any classical OOP language, you just inherit it. In this case, I add the property B. If you need more things to add, you inherit it once again. You have like method Y and method Z. If your language supports, you can even replace a method. And typically, at the end of the day, it ends always like that. A lot of pain and suffer. But look, there is one useful thing there. You see, one useful thing.
I have a question.
So, yes.
I have a question. What is that thing under the useful thing?
I'll tell later in
okay, cool.
in a few slides.
All right.
Okay. So it doesn't really matter. These are all things which do something, whatever they are. Constructors, events, you name it. So, but you actually need only like constructor, property B, and method X, and this useful thing, because it's useful. In order to have all these four, you must. Unfortunately, they all declared in different classes, so you must use this big hell on the earth just to have four of them. So if you think I just came up with this just now, you probably all have stories like that with the large classes you have with hundreds of methods. And when I say hundreds of methods, I'm not exaggerating, because let's take a look at how you put a text in Windows application. So this is a label from WPF or Silverlight or whatever. So what you do in order to just write some text in .NET? You use this label class, which already have 7 parent classes. Okay, it's design choice. 1 constructor. 211 methods. I went to MSDN and count them all. It has 130 properties. I count them all as well. And it has 55 events. I count them all as well. They are actually properties as well. And there is also 1 static field and 1 attribute. For those who don't know .NET, Everybody knows .NET, right? If you don't know .NET, this is like annotation in Java. So if you think this is okay, this is good, this is all right, just to show some text on screen, if you think that's good, I would not agree with you. I think that's a superclass, and you know what superclass is. It's just a big, ugly hell on earth. So what we did? We decided to rethink the object-oriented programming, basically. So let's assume these things on the left are kind of a behaviors you can choose from, and then you choose some of them, like only the 4 you need, for example, and somehow magically you like combine them. I'm not sure how magically, just some magic works there. And then you get this little thing you actually want. Constructor, method X, property B, and useful thing. No other stuff. And typically, at that point of time, C# and Java developers go like this, like, that's too much magic now. Like, how about like I don't know, conflicts? How about constructors? How about you name it? And these are all the technical questions which you don't know how to solve because you just always learned, well, classic languages, classic OOP languages. So to make that happen, we invented stamps. By we, I mean that guy. That's Eric Elliott. You might have heard of him. He's a JavaScript guru out there in the San Francisco. He invented them like 3 years ago or so, or 4, or maybe 5, doesn't really matter. So what are stamps? Stamps are these boxes on the left. They are the behaviors. Those you can combine. Stamps are composable behaviors. You can like merge these stamps, magically merge those stamps, and get a larger stamp with more information inside. Stamps are not a library or module. Stamps are as specifications. In our case, it's a JavaScript specification only, because that's what Eric Elliott is doing. He's doing JavaScript. So there is a promises specification in JavaScript. So we created our stamp specification. And various stamp implementations are compatible with each other, just like promises. And stamps are factory functions. Like, you probably know that classes are factory functions, actually a set of factory functions if you have multiple constructors. So stamps are factory functions, okay? From now on, there will be plentiful of JavaScript in many slides further. And I assume you at least know how to read JavaScript. Don't need to write it, just read what those curly braces and angle brackets mean. That's all I need from you. So what we specify is the only thing in this specification is the compose function. So this compose is a function. And you probably don't know, but if you know, that's good, that functions in JavaScript are also objects. So we just import an object, which is a function. We try to keep the specification as short, as tiny as possible. Nothing really, well, doesn't matter. So example of how I create a constructor behavior or constructor stamp. So here it is, I'm calling the compose function, and I give it a new object which have one property called initializers, which is an array which have one function. So down below, if I will call the stamp called ctor, so this is a stamp, the compose function creates stamps. In .NET, this would create a class or return a class or declare a class if it's a compiled language. So assuming this is a class, kind of a class, but actually it's a stamp, a factory function. So down below, if I call this factory function, it will return me some object, but it will execute this line and print this message to the console. Same thing, a method. So this is how would I declare a stem with a method. Same compose function, I say that it will have one method, method x, and here I'm creating a object instance from that stem, and it's got the method x, you can call it. Same thing with the properties. I declare that using same compose function, I declare that this stem will have property, and then I create an instance here, and it will have this property. Clear so far? All right, more complicated. The useful thing you asked about. So I'm using the same compose function, and I'm saying that there will be a static property on a stem itself, and this it name will be useful thing, lowercase. So down below, I'm not creating any objects. I'm using it like a static class, but in our case, it's a stem which have a function. So it's like a static function from that class. I will be using statics a lot in a few other slides. So if you do not understand that, ask me again. I will explain it in different way. But this is, please remember that. So now, the magic. So this is how I grab the same function and I just pass all those previous stems, and it will give me a stem 1, which is just a stem larger, and this compose function does that magic. Oh yeah. So the compose function accepts both JavaScript objects plain with the curly brace or stems. It distinguishes between them. Okay. And this means that the stem 1 will behave like this. I will create the stem 1, this constructor will be executed. I can access then method x and property b and from the object instance, and then from the stem itself I can accept the useful thing. It's kind of a multiple inheritance. Not really. There are more. So all the previous code in the single slide with the same magical compose function. As you can see, I'm just drawing the lines. It's just a beautiful slide I put up so that you could really understand what's coming from there. But it doesn't really mean that you have to create 4 different stems to have and then combine them all. You actually can specify them in a single compose call and just list them all like properties. And then the same stuff happens over here. As it happens over here. Easy. So far, simple. Now, getting down to complications. So, about stamp.compose, it's kind of a static method as well, stamp.compose, but it's present in each stem. If you remember this stem 1 from previous slides, I hope you actually see all that from the far distance. Sorry if you don't. So, similar to promises.then function, the stamps have .compose function, which is actually the same magic. And then you can grab this stem, call the .compose from it, and pass all the other 3 stems, and it will result with exactly same stem as here. So these are identical. And you can use this stem word compose in a different manner as you want. Down below, I'm using a standalone compose function and then the .compose method from the generated stem. So you probably already understood that every compose call, doesn't really matter if it's .compose or the function, it will create a new stem. And the compose actually merges the metadata from provided stems. Like, merges the metadata together and the stem becomes just a little bit bigger. Now, let's get down to the metadata. So you remember this stem, right? What if I print a stem.compose? As you already know, in JavaScript, functions are also objects. So what we do, we collect the metadata in this .compose object, which is also happen to be a function. This is how we are reusing it. It serves a double purpose: either compose this stamp with something else, and also to store metadata. So if I print it, we will see that the .compose is a function which have property initializers, also have property methods, also have property properties, and also have property static properties. And at the end of the day, the stamp.onCompose have 4 different kinds of metadata on it, like attached. We not only allow you to touch this, we encourage you to do whatever you want with this metadata. It's especially, we are keeping it public, we are keeping it available so that you can manipulate it and do whatever you want with it. Yeah, that's it. I will tell you, I could tell you why, but it would take too long. Now, let's take a look at a classic C# example, like just a simple class. And I will convert it to stamps, but please don't read what the code is actually doing. It's just irrelevant. It's just a random example from the internet. Just understand the idea behind, please, if you can. So, this is a classic, like a class, right? We are configuring the class with some metadata, which are attributes over there. You see up there, these two. Then we are configuring the class members using both inheritance and just declaring 2 more methods. So this is how we set up the members. Then we are configuring the object instance with the simple dependency injection over constructor. And other, well, doesn't matter. Doesn't matter. So, how to set up a class behavior in C# or Java? Typically, we're using all the features a language has, in our case C#, and different patterns. This is how we set up our class and the instantiated objects. So all these on the left, this is nothing else but a process of configuring your class. The process of collecting metadata about your class and the future objects. Stop me if you're feeling confused, because this kind of overloading your brain could be already by that time. We are using all these language features: extension, annotation, attributes, interfaces, and then lots of patterns like dependency injection, composition, proxy, wrapper, decorator. Most of the design patterns are like the way to set up your class. So how you do it with stamps? In stamps, you're using this thing called compose. So this thing on the right is the way how you configure your class, how you collect the metadata about your, stamp, how you collect the metadata about your stamp and the future objects instantiated from that stamp. Okay, when I realized that some time ago, I was like, why the hell I need all those design patterns? Why the languages are so limiting me? And why I even learned all those books and design patterns? That was my actual reaction. Like, I was mind blown at that time. Okay.
You've changed your glasses.
Yeah. I bought these like a month ago. So they were on sale. Okay. So this is an example of a stamp. I call it base test. I say that the stamp will have 2 static properties. One of them is suit, the other one suit, right?
Sweet.
Sweet. Always fine.
Complete.
Sweet. And the test. And down below, I'm using them. You see, I call base test dot sweet and dot test. Easy, right? Simple. And the same code. As you can see, the base test dot sweet, it returns this dot compose. So in JavaScript, this references would reference the stamp itself. So this is how you access. It doesn't really matter if that base class, base test, or something else. Doesn't really matter which stamp. It will access itself. So this references the stamp. So what it does, it just adds few more metadata. Doesn't really matter what metadata right now. Few more metadata into itself and returns a new stamp. As you remember, the dot compose always returns a new stamp. So it's immutability. Same thing in the dot test. And down below, I call base test dot sweet, which returns new stamp. Dot compose, obviously, it also returns new stamp. And these two also returns new stamps. And at the end, I've got this full stamp, whatever. So far, easy, right? Okay. Now I'm using this base test from the previous slide. I assign it to test example stamp, and then call .sweet.compose.test.test. Easy. Now let's compare to the C#. Similarities, isn't it? So here I'm assigning some, providing some metadata, just like here I'm assigning it to the metadata. Yeah, we call it in .NET is also metadata. So similar. Then here I set up. This is actually the inheritance as well. I actually get everything the base test have, and basing on it, I'm creating new stamps. So this is how I set up my members, and this is also how I set up my. Skipped a little bit, sorry. This is how I set up dependency injection. There are other ways to do that, not only this one. And this is how I set up two more members, and it's metadata, as you can see. It's all very similar. So what I'm trying to say is that I'm using the same compose thing here, 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 and here to get whatever this class is doing. And this is not only that example. Anything in classical OOP can be done like that with stamps. But the stamps are more flexible. The stamps are more free. They do not limit you. They do not throw exceptions. So it doesn't really matter. What matters is that if I will console.log this metadata, you remember the metadata is attached to the .compose object, which is a function as well. And we'll see that it's got these four different kinds of metadata: deep configuration, properties, configuration, methods. And let me show you them. So this is where I set up the properties, and this is where I set up deep configuration, methods, and configuration. Now, there are four kinds of metadata in our specification. You remember I mentioned the specification in the beginning. Doesn't really matter what they mean. They will differ for different languages. In JavaScript, they are like this. Now, let's get to this magic. The magic actually is nothing else but just merging dictionaries. If you know what this JavaScript function is doing, it just merges dictionary key by key. The second argument will in case of key conflict, the second argument will override the key in the first argument. And this is by design. You will be asking your questions about conflicts in method names. I'll have an answer for that, but later. Also, we merge some other metadata using the .merge, which is doing the deep merging, which is like tree merging. In other words, if the values in both dictionaries are also dictionaries, then we will merge them as well. So this is deep merging. And the initializers, we just concatenate them. That's it. This is the entire magic.
So if I wanted to preserve the behavior of the parent, and could I just assign the parent as a property and then refer to it in my new method,
Exactly.
which I'm then shadowing?
Yeah, this is has a composition pattern.
Right. So you can always preserve the previous incumbent.
Yes, you actually can do anything, not only preserving that, and I would call this also a metadata.
Yeah.
You can preserve anything. Questions? Good.
What does, merging trees, it's got an NQ performance cost. I mean, that's one of the reactor. So is there a limit to, how crazy would you make that, anyway? You've got to understand it.
Typically, this merging happens only once when the application starts in JavaScript. In other languages, this would be just on a compile time, theoretically.
Are you handling the dependencies between properties that are needed by the method? So say your different stamps need different properties. Is there any dependency resolution or error case, or do you just get a null reference later?
In JavaScript, this is typically a runtime error.
But does the stamps help you with this?
In
Because
stamps,
composing these little pieces that each one will have some dependencies, I presume that will build up.
yeah.
I think the key is that your stamp should be a behavior that you're using, not a method. So if you think behaviors, that'll be a function and
Something for it.
private functions or whatever else if you've got them. So you want that block of logic. So
Yeah, but
more self-contained.
he's saying that what if a stamp depends on the other stamp?
Or there is two stamps which depends on some sort of properties.
Yeah, stamps depends on stamps. First of all, it's up to you. It's same as in classes. If you are trying to reference a property which exists or does not exist. With the if IDEs would support stamps, you would have no problems. You would get it underlined. If stamps would be a compile time thing, not a runtime thing like in JavaScript, you would get a compile time error. And yeah, that's it, I hope. Moreover, answering the question about conflicts, what if two different stamps declare the same property? Because you would definitely ask it. Every time people ask it. In my experience of using stamps for, look at in the corner. Here's a large one.
Get away from pizza.
Okay.
The further south you come, the bigger they get.
I'm not applying for work in Footworks. No, really. Sorry about that. Yeah, sure. Of a crocodile.
They're going to knock this building down, apparently. So I think they've started. It's true.
So, in case of conflicts, in my experience, I have never had any conflicts because, first of all, as he said, stamps are behaviors. They should be like independent from other stamps. But if you need them to be dependent, then if you need them to maybe have conflicts, then the latest stamp will override the first stamp, but you might lose track of it. So usually, stamps are really small. And the end objects, I have never had an end object more than 10, 15 methods and end properties and everything together. So stamps are typically so very small, so the problem of conflict does not really rise. I had one person asking this question to me because I'm consulting people about stamps, and he solved it really easily. He saw where the problem is, he wrote the code, he was really easy to solve it, the conflict. If you really need a conflict resolution or compile time or runtime error, I'll show you later how it's done, how it can be done in JavaScript at least. More questions. I hope I answered this one. More questions?
What about so static versus instance, like properties and methods? So you showed us before, you got like your stamp object and then like just a dot, and then you can get to the static stuff. What if you want to get to the static stuff and also the instance stuff?
Yeah, you can get it all. Yeah, sure. What do you mean?
What's the difference? Like why are they made static if all the properties are just kind of accessible through static anyway? When you're going like new object.
I don't think you can access the properties from the static members.
Yeah.
Because you need to, because to access any of the member variables, you have to call the factory. The factory returns you a new object. So the compose returns you a factory, which has a bunch of static methods on it, and then when you invoke the factory, then you get the instance of the factory.
Do you invoke it?
Yes. So every stamp is a. Assume every stamp is a class. When you invoke a class, you receive a new object. Same here thing. If you invoke this factory function, you will receive a new object. And the information about this object is collected in that metadata. In statics, you do not create any objects. You implement those static methods yourself, as you saw. All right. Few awesome features you didn't notice. I will skip one JavaScript related, and we'll go to that one. So you can override the .compose. What does it mean? Is that compose is doing that match. Oh wait, forgot to say. This is the main slide of my presentation. This is like the core. This is like the entire idea of why I'm actually talking here. This is the main slide, the main idea of OOP. All right, let's move on. So you can override the .compose. What this means? This means that this magical function you just saw, it doesn't need to be that. You can re-implement it or reuse it in let me show you. So assuming I have this .compose function, and then I have this infected compose. I call it infected compose function. This is JavaScript. I hope you recognize JavaScript. What it does, it logs logs arguments to the console, and then adds few more metadata, and then runs the original compose with the same arguments. So it's like just dumping whatever it received, and then call the original compose. And then here, I'm creating those familiar to you 4 stamps using the infected compose function declared above, and creating stamp 1 like this, also calling the same infected compose. So you see these 5, they're directly calling this one, like straight. Then I'm using from the stamp created from this infected compose, I call .compose and .compose again. So in these 2 cases, that function will be called. Because you see, I added few more metadata to all the new stamps that it will have the .compose static method. But this, it references the infected compose itself. So it's like circular reference, kind of. And this means that the console log will be called 7 times. Are you following me?
Instrumentation, AOP type stuff.
This means you can insert any kind of logic inside here. Like stripping anything, checking conflicts, collisions, do whatever you actually want. And moreover, if you create a stamp from it, like let's say you have created a collision check collision check infected compose. Then you created a single stamp from it. And then wherever you merge this stamp into, wherever you merge into any other stamps out there, this means that whenever you create an object, it will be, sorry, not whenever you create an object, whenever you then
So it acts like a base class that you can inject, and anyone that composes off that object then receives that implementation.
Yes, so everything inherited from this will be doing this logic, which is checking conflicts. If you really need this, you actually don't need it with stamps, but if you really, really want it, you can implement that. Also, this thing is useful for tracking composition in JavaScript in real time. It could be useful. Tracking, and also you can like collect all the stamps you have ever merged to some kind of a metadata inside. Typically, it's a configuration.
So I could
metadata.
use this to replace all my like dependencies with like test mocks.
Exactly. This is exactly how I'm using it most of the times. I really like how the dependency injection here works. You can inject dependency like this with a composition, and then in real time, whenever you create an object, you pass your arguments to your stamps. Well, stamps, of course, they accept arguments, and those arguments are available in the initializers, if you still remember what initializers are. One more thing, JavaScript related. So again, we are creating stamp called my user. It have only one initializer, then it logs the password length to the console, so secure. Then, if you're using this stamp incorrectly, passing just wrong information, it can, in JavaScript, it throws different errors. So what I want my errors to be more standard and readable, because cannot read property length of null is not really readable. So what I have is an ArgumentChecker stamp, which have a static function called check arguments. Then I pass to it an object which is also a dictionary, and I say that password must be a string. And then what I receive, I compose here with my user, and I call it myself my safe user. Then if I call incorrectly the my safe user, the exception will be exactly the same. Somewhere inside, it will check the arguments and throw a meaningful exception. Argument password must be a string. And let's get down to the implementation of this argument checker. So, as you saw, argument checker have one static method, which is called check arguments, which receives the key value map. What I do, as you saw previously, I'm doing the same trick, calling the this.compose, add few more metadata to the deep configuration storage, let's say, and return a new stamp. What the other thing in the argument checker stamp is the initializer. So what it does, it grabs this, say, the metadata from the previous slide, I collected from the previous slide, and then runs across the received options over here, and then throws a meaningful exception. Let me show that all in a single slide. So this is how I collected my metadata called deep configuration. I put it over here into it. Then I'm using the, you still remember, right, that all the metadata is available from the compose object, which also happens to be a function. So I receive the stamp in the initializer. This is our API in our specification. So I receive this stamp, I get the deep configuration from it, and then I get to this property from it, and I get my map I was collecting from the previous times. And then I iterate over the map and check if options have everything, and then throw a meaningful error, if anything. And but to my taste, that's just too much code for a simple feature like that. So we have implemented a special module called Stampit, which can shorten this code. Take a look. So this is the module Stampit. It creates a new stamp. Then I call these 3 static functions on it. So what Stampit does, it adds a bunch of handy static methods to every your stamp. So actually Stampit is nothing else but an infected compose you've seen previously. So it just infects your stamp with a lot of different but handy methods. And in this case there is a .statics, .deepconf, and .init. It just shortens the code and makes it more readable to my taste. You can wait. You can check the differences. You see, there are just a little bit less lines, less things. Okay. So when to use stamps? Well, if you were JavaScript developers, I would tell you instead of classes, obviously, but stamps cannot be that easy embedded into the C#. When you have many similar but different models, for example, in games, have you ever heard of Craft Wooden, Old Unique, Improved Warsword? All these words, each one of them can be different stamp. For example, or from my job, subscription types. So we develop service. Service have 3 tiers: Free, Pro, and Enterprise. Also, you can be charged yearly or monthly, or direct debit or invoice, or credit card or bank account, and other. So all these things can be stamps, better be stamps, but they're not. We have 12 or 13 levels of inheritance, unfortunately, something like that. Yeah, shit happens. And in your case, I'm pretty sure you have that kind of a similar but different models in your code. You always have this problem. The problem of diamond, for example. You say you're developing a game, you have an object class called game object. You inherit it once for animals, once for robots. Now you have 2 different classes. But now you need to create a robot dog. This is called the diamond problem. You just cannot merge 2 classes in classic OOP. It's easier with stamps, as you can see. So stamps are really great for dependency injection in complex logic. Like that just comes from my experience. I really love it for that feature. In HTTP request handlers, I usually abstract. We're developing a bunch of microservices. I typically abstract logging, HTTP, Kafka connection, and whatever other I/O we have with stamps. It's so very much easy to do with stamps, because stamps have both early dependency injection through properties and late dependency injection through arguments to the stamp. And in your case, what else I find? Have never found this, but I'm pretty sure that if stamps were used as UI components, it would be. Stamps are really great. I think that stamps are really great fit as UI components, as UI. You call them differently in different frameworks and languages and technologies, but I call them UI components. So just imagine you have an UI component, then you merge all these different behaviors into it whenever you need it. It's not like you have 2 properties, is resizable and size, and then an event resized, just like it in .NET often. you just have all these resizable kind of behaviors. If you merge it to your component, then you have it. Okay, do you have any questions? Shoot them now, because I'm coming to an end. So, if you're building a new language, or if you're working on a language currently, I don't know, maybe C# maybe, then please omit classes. Consider stamps or any other composable behaviors. Like you probably, if you're familiar with Rust or Go, they have kind of a stamps. There are also traits in that language. I mean, Scala and Groovy. Yep. So, but they are quite limiting actually. Traits are limiting. They throw exceptions if you have conflicts, and they do not allow you multiple initializers, or they do actually, it depends. And sometimes they do not allow you to insert static methods. So they are limiting in each language. They're for some reason limiting, as they call it, traits actually. So stamps are kind of variation of traits. Just imagine this is a C#. Just imagine you can write things like that in C#. This would mean that your classes would be much shorter. Currently there is a trend in at least JavaScript side, but I think it's coming global. The language is becoming modular. Not modular, you can implement like language features yourself. I heard that in Swift you can do that. In JavaScript it's definitely a long-term feature. And maybe other languages you can embed your features in. I'm not sure. But it would be good to implement. I would really love to implement stamps to any other language out there, not only JavaScript, as a part of the syntax. For example, C# syntax. If you can help, if you actually know a way to extend C# syntax with your own language constructs, I would really like to hear you after the meetup, because I want to learn how to extend languages, all kinds of them.
So you can use Roslyn to basically do exactly that, because Roslyn will give you the AST, and once you have the AST, you can just do whatever you want. But what it might mean is that you might have to generate you have to generate classes ahead of time.
Yeah, I got it. Yeah.
Whereas if JavaScript, you can just kind of do the ad hoc polymorphism just whenever.
Yeah. So I have this medium.com blog where I post things about stamps. I was able to tell about maybe 1/4 of all the information and tricks and things you can do with stamps. So if you're interested, there is my handle. I'm Corsair everywhere, basically, in GitHub and Twitter. That's it. That's my last slide. Thank you.